All right, let's begin with the practice examples in chapter 15. These are within the text, not at the end of the chapter, but within the chapter itself. And the first one is 15.2a. So we're given the following information about a reaction involving nitrogen gas and its combination with hydrogen to form an equilibrium with 2NH3. And this is going on at a temperature of 298 Kelvin, and we're told that the K for this reaction is 5.8 times 10 to the 5. Excuse me. So some of you have asked me questions about why this is not clearly marked as a Kc or a Kp, but in this particular type of reaction, it's not important to arriving at the correct answer. It could be one or the other. So the question is, what is the K value for the following reaction? 1/3 N2 plus H2 gas, and that's in equilibrium with 2/3 NH3, and it has to be at the same temperature, or else the following relationship between the two Ks is not valid. So what is K for this reaction? And the way we go about this, of course, is to see how the two reactions relate to each other. And so clearly this one here is the top one divided by 3. And so rather than say that it's divided by 3, what we're going to say is that the top reaction was in fact multiplied by a factor of 1/3. And therefore, the K is the original K value, which in this case is 5.8 times 10 to the 5, raised to that factor, which the reaction was multiplied by. And so the cube root of this number turns out to be 83. Okay, so that's A. Now if we look at B, it's same idea, a little bit different. If we look at B, we've got the same question example. Nitrogen monoxide gas plus 1/2 O2 forms an equilibrium with nitrogen monoxide gas, and this occurs at 184 degrees Celsius. And again, we're given the K value for this reaction as 1.2 times 10 squared, or simply 120. And then the second reaction that we're given is the one for which we are asked to find the value of K. And it's the breakdown of nitrogen dioxide into 2NO and O2. Same temperature, so we can relate the Ks. What is the K value for this reaction? So same idea. Look how this reaction is related to the one given. And we see that this reaction is this top one reversed, so multiplied by a -1, and then doubled or multiplied by 2. So in all, this second reaction is equal to the first one multiplied by a factor of -2, so that the unknown K that we're being asked to calculate is equal to the original K value raised to a factor of -2. Now sometimes, especially on an exam where there are multiple choice answers, the answer could be left in this form rather than work out its simple numerical value. And I just want you to recognize that this form is the same as writing it this way. Okay, so that negative sign really means that it's the reciprocal. And anyway you look at it, this value is, from the calculator, 6.9 times 10 to the minus 5. So that is the new value of the reaction equilibrium constant K. Let's take a break.